Alright, here we go. We are going to talk about similar figures and some of the properties of similar figures. We've already kind of talked about similar figures as far as how to set up proportions, find missing sides, but this time what we're going to do is look more at the areas of similar figures and see how those kind of work out. So what I did is I drew two similar rectangles. They might not look very similar, but we're going to assume they are. This first one here, I guess we'll call it figure A. Figure A, I got a 5x8 rectangle, and then figure B, I have a 10x16 ratio. So if you look here, the ratio between the corresponding sides, or at least the sides that look corresponding, it's going to be a 2-to-1 ratio. Okay, so now I want to look here at the perimeters and see how those relate. Alright, so the perimeters, if you see that, you have 52 to 26, and that actually reduces down to 2/1 as well. So we're going to say that the ratio of the perimeters is the same exact thing as the ratio of the sides here. They both have a 2-to-1 type of ratio. Now when you look at the areas, those are going to be a little bit different here. Notice that you got 160 and then 240, which actually reduces to 4/1. Alright, and I guess this is going to come from taking your scale factor, the 2-to-1, and squaring that ratio right there. So if we do like 2-to-1 square, that gets us the 4/1. Alright, and that's kind of the whole idea with the area of similar polygons. So if two polygons are similar with the lengths of the corresponding sides and the ratio of A to B, then the ratio of their areas is A squared to B squared. So you square your ratio to find your other ratio, to find your other area. We'll use that here in just a moment. Write the ratio in fraction form here. So we'll say if we're going from A to B, we want new over old, so technically we want B over A. And write the ratio. So write the scale factor, I guess. Yeah, I guess this is right down here. So the scale factor between the two, I guess, is B to A, and then the area scale factor, or not the scale factor, but the area ratio would be B squared to A squared with this figure right here. I guess that's kind of what it's asking for there. It's not very clear. Find the ratio of the perimeter and the area of the given figure. So we want to look at what sides are corresponding. So you got the one little hoop and the one little hoop. So you got 3 and then you got 4. And I think we're going from small to big here. So we're going to say the ratio of the sides is 4:3. Therefore, the ratio of the perimeters, that usually is going to be the same. So we're going to say the ratio of the perimeters is going to be 4:3. And then the ratio of your areas, you're going to square that, so that would be 16 to 9 right there. We'll make these charts quite a bit in this unit, or I guess in this lesson today. I call them the SPA charts, or the SPA charts. So ratio of the sides, ratio of the perimeters, and then ratio of the areas. Make sure you square it. It's kind of like your units. Like if you have units, then you're going to have units squared for your area. So anyways, that's how you do that. Should be pretty straightforward. Find the similarity ratio for the given figures. So check this out. They give us the ratio of the areas right here, with areas 81 and 25. I guess they don't really tell us which one's new or old. So I'm going to write it as 81 over 25, but it doesn't matter too much. And actually, I'm going to do this. I'm going to write SPA, make one of those charts. It's 81 to 25. Therefore, if we think backwards and we square root instead of squaring, we square root both of those numbers. That'd be 9 and then over 5. And then therefore your perimeter ratio should be the same. So we're going to say the ratio of the sides, or the scale factor, is going to be 9:5. Okay, look at this. Areas with 10 and 360. So I have a lot of people say when you make your SPA chart on this one, say, well, can't really do the square root of 10. You can't really do the square root of 360. But if we go and reduce down the fraction, we might be able to eventually. So this one here, whoops, that'll be 36 over 1. And then we can do the square root of 36. That should be 6. we can do the square root of 1. That should be 1. So this will have a 6:1 scale factor. And then that is it. Okay, kind of the same thing, I guess, for this one here. You got areas of 128 pi over 18 pi. And that will be for the areas. And we're going to do the scale factor and perimeter. So once again, I'm going to divide these two. I'm going to reduce it down, and we'll see if it comes out clean. So the pi's will cancel each other out since they both have it. 128 divided by 18 doesn't come out to a nice number, but it does reduce down to 64 over 9. So I guess dividing both the numerator and denominator by 2. And then we can go back from there and square root the numerator and square root the denominator. So that'd be 8 over 3 for both of those. Okay. So yeah, there you go. Well, actually, this would be our answer. Scale factor is 8 to 3. Okay. Let's see what this one's saying here. The perimeter of an equilateral triangle is 9 times the perimeter of an equilateral triangle G. Oh, okay. Equilateral triangle E is 9 times the perimeter of equilateral triangle G. The perimeter of G is 15. What is the length of one side of E? So we'll think about this here. I'll draw 9 times the perimeter. So the one that's bigger, I guess, is E. Triangle E is 9 times the perimeter of triangle G. Okay, so I'm not sure what the side lengths are, but check this out. The perimeter of G is 15, and they said equilateral triangle, so we know that the sides are all going to be 5, right? And then we know that E should be 9 times that right there, so E should have sides of 45 each. All right, and that's because if we go and do the little SPA chart, the ratio, we just kind of talked about this, the ratio of the perimeter should be the same as the ratio as the sides. All right, and then, yeah, so they should be the same ratio. And then, yeah, so we can just multiply by 9, get 45 there. And then if you wanted to talk about your areas, it'd be 81 to 1 ratio, but they didn't really ask for that in this one. All right, this next one here, I think we actually use our ratios and find an unknown area or sometimes an unknown side length or an unknown perimeter. So look at this one. For each pair of similar figures, the area of the smaller figure is given. Find the area of the larger figure. Okay, so, okay, I guess we got 2 different problems here. So we'll start with the rectangles SPA. We're going to make that chart to help us kind of keep everything organized. Notice here it looks like we got a 7 to 15 ratio, and it looks like we're getting bigger, so we'll say 15 over 7. Okay, so that means your perimeter ratio better be the same. And then for your area ratio, you want to square that. So I believe that's 225 over 49. Okay, so then they say, all right, well, we gave you the area of the smaller one. Now go find the area of the larger figure. Right? And since we have this ratio, we can set up a proportion like we've done in the past. So we're going to say 225 to 49 equals, and then since that fraction's in the format of big over small, you want your second one to be big area, which is unknown, over the smaller area, which is apparently 84. And we're going to cross multiply and divide. So I'll multiply 84 times 225, and then I'll divide that by 49. It's not coming out super clean. Apparently that's going to be 2700 over 7, but if you want to use a decimal, that'd be 385 and then 0.771 technically. And then we'll make sure to get our units, so that was centimeters, that'll be centimeters squared. And that's pretty much it for that problem. So set up your SPA chart and then go from there. Let's get some different colors going on here. Now this one here is a little tricky. You got to pay attention to the side lengths and which ones correspond. So I'll start. We'll make a SPA chart, find the ratio of the sides, and then go from there. So notice that the one side that's given on this triangle is across from the double hoop. So we need to go to the side across from the double hoop on the other triangle. So that'd be a 5-to-8 ratio. Actually, 8-to-5. If we're going to go, new over old. So that means your perimeters are the same. That means your areas are the squared version of that. So 64/25. All right, and then we're finding a new area, so we want to use the area ratio. So we'll go 64/25, and then equals, and they gave us the area, the smaller one, so I'll put that in the numerator. If I got big over small for my fraction, you need big over small for your second fraction. So then we'll put x there in the numerator, and then we'll cross multiply, divide. Probably won't come out super clean again, but we'll see. So 64 times 18. And then divide that by 25. That one comes out, I guess, a little bit cleaner. It's 46.08. It's actually a terminating decimal. And then we'll get the units there, so there's inches, so that'll be inches squared. And that'll be it. So I know there's a lot of homework questions that are like that we use the scale factor, find the area ratio, and then find the unknown area. So what do we got going on here? For each pair of similar figures, find the scale factor of the perimeters. So we don't even need to find an unknown side, we just need to find the scale factor. So we'll go SPA. And they gave us the areas, so that's 50-8. And I know that reduces 25/4. The biggest problem I've seen with this section is people forgetting to reduce their ratios down. And then they say, well, I can't do the square root of 50. Well, reduce it down and maybe you will be able to do the square root. So we can do the square root of 25, that should be 5, and then we can do the square root of 4, that's 2. And then we can fill out the rest of the chart. And then what are we doing? Finding the scale factor, so that would be the ratio of your sides. And then actually, you know what, now that I think about this, I think I have this upside down actually on all of these. Because it looks like you're going from big to small, so actually you want it flipped upside down here. You want a 2-to-5 ratio. Some teachers don't count off for that, but technically we would want to flip everything upside down here. I mean, I guess it doesn't really necessarily tell you which one's the new and old, but usually we read from left to right, so I'll make sure to address that on this next one here. So SPA, so it looks like we are getting bigger. So we want the new, the 27/12. All right, and those are both divisible by 3, it looks like. So that'd be 9 and then over 4. Then we can square root both of those and get 3/2. And then there's your scale factor. And then you want your new over your old. Okay. I think there's just a couple more here. And we'll talk about the non-proportional change. Find the ratio of the shaded to the unshaded of the perimeters and the areas. Okay, so check this out here. We know that side AC corresponds to DF, so those two sides that they give us, of course, are going to be corresponding. So we'll go sides, perimeters, areas. And we'll say, okay, sides is a 15/12 ratio. So then those are both divisible by 3, so that'd be 5/4. And then we know the perimeters, same ratio, and then we know the areas, you just square that. So 25/16. Okay, here's another one of these ones where we find the unknown right here. So in this case, we're going to find the unknown area. So we'll set up our scale factor. It looks like these two sides are corresponding. So sides, perimeters, areas. 20/14. Those are both divisible by 2, so we can go 10/7. So the perimeters should be the same, 10/7, as far as the ratio. And then the areas will be the square of that, so 100/49. And we'll just punch that out, 100/49. Now, oh, by the way, I'm using the area ratio because they're trying to find the area. So 100/49. And then notice this time they gave us the area of the larger figure. So I'm going to go 400 and then over x. Then you can just cross multiply and divide. So 400 times 49, and then divide by 100. And that gets you x equals 196, and then don't forget your units. So that'll be inches squared. Alright, that's about it on that one. Let's see what's going on with this. Find x, y. Oh, and notice here they gave us the ratio of the areas. So let's see what's going on here. S, P, A. And we got 378 divided by 168. And what I'm going to do in my calculator, so I don't have to think too much, I'm just going to type 378 divided by 168, and then I'll hit the math and then convert to a fraction. And apparently that gives us 9/4, so it actually reduces down pretty nicely there. And then we can do the square root of 9, that's 3. We can do the square root of 4, that's 2. What are we trying to find? We are trying to find a segment or a side length, so use your side ratio. So we'll say 3 to 2, and then equals, it looks like we have the smaller one, so we'll put the 8 in the denominator, and we're trying to find the bigger one. So when you cross multiply and divide, that should be 12 centimeters. Alright, next one. Perimeter ratio for the two similar octagons is 3 to 2. The larger octagon has the area of 75. What's the area of the smaller octagon? So we're going to make, once again, an SBA chart. And they gave us the ratio of the perimeters is 3 to 2, which means the scale factor is also 3 to 2. But they're asking for the area, so we need our area ratio. That'll be 9 to 4. So we'll say 9 to 4, and then it says the area of the larger octagon has an area of 75. So notice here the format, I got big over small, so your second fraction needs to be big and then over small. And then cross multiply, divide. 75 times 4 is 300, divide that by 9, and it looks like it's 33.3 repeating. If we want a fraction for that, that is technically 100/3, or you can say 33.3 repeating. And then what's our units here? They didn't give us any units, so we can just say units squared. Make that look nicer. Alright, some of these here will have non-proportional dimensional changes. Alright, and that just means the sides will not be proportional, obviously. Alright, so like proportional sides, usually you're taking a side length and you're multiplying it by some type of scale factor. Notice like on this example here, this is an example of non-proportional change here. You're changing each side the same, but it's not by a scale factor. We're saying add 2 to both sides, and that'll change things around. The figures won't be similar. So that's kind of the difference there on that. So Botany Club plans to increase the size of the rectangular garden by adding 8 feet to each dimension of the garden. How many more feet of fencing will the club need to buy for the proposed garden that it would have bought for the current garden? Alright, so I guess we're going to go and then find the different perimeters here. So let's find the perimeter of the first shape here. So that's just 22 times 2 and then 16, or plus 16 times 2. So the small garden, I'm going to just say P and then S for the small garden. The perimeter of the small garden apparently is about 76. That's basically 22 plus 22 plus 16 plus 16. All right, and then we're going to add 4 to those dimensions there. So we'll have the perimeter of the large or the new garden, if you want to do that. If you just think about your new dimensions here, I mean, there's multiple ways to think about it. But the way I see it, I guess, is you're adding 4 to 22, but you're adding 4 twice. You got this side here and then this side right there. So actually that dimension going up and down is 30. And then this dimension should be 24. So you just go 24 and then plus 30 and then times 2 because you got 2 of those sides. That'll be 108. And I don't know what are we, feet on both of those? So how many more feet of fencing would you need? Well, you just do 108 minus 76, and that gets you 32 more feet, I guess you should say. And then I guess we'll go ahead and compare the areas. I guess on those, so the areas, the area of the small, you just want to go 22 times 16. I'll just use my calculator for that. That's 352. And then feet squared. And then the area of the large is, I guess, 30 times 24. It should be 720 feet. All right, and these will not be proportional as far as the change goes. 720, I guess we'll do this, minus 352. I guess the difference is 368 feet. Feet squared, and that's the difference, or how much greater the area is. But these two numbers right here, they have no tie together since it was non-proportional change. So anyways, that is it for our lesson.